let's say I've got two vectors. Okay, let's say our first vector is a v vector, and it's a sub 1 I plus b sub 1 j, and I'm just using the subscripts there to indicate, hey, that's my first vector. All right, and then let's say they give me a second vector, and we'll call it w. All right, and so since it's the second vector, I'll use subscripts of 2. So a sub 2 I plus b sub 2 j. So there's our two vectors. Dot product means we multiply the vectors. So our formula, the v vector times the w vector, is going to equal whatever I get when I take a sub 1 times a sub 2. So I'm going to multiply those two numbers. I will add to that b sub 1 times b sub 2. So what's that going to do? It's going to give me a real number, numerical value. So you're going to get answers like 10, 23, 44, 16. Okay? Negative 24. You can have negative numbers as well. All right, but that's literally all there is. You don't even need your calculator for that. You're going to, as long as they give you the a I plus bj form, take your a's, multiply them, take your b's, multiply them, add them up. Okay, so is that simple? Seems simple? All right, let's do an example. It's going to maybe say, given, maybe say the v vector is 4i minus 2j, and my other vector, lack of creativity here, we'll call it w. We'll just stick with the same names. All right, maybe negative 3i plus 5j. Now I can say find the dot product. I can be a little bit more specific. All right, and if I said find the dot product, you'd multiply the two. But I could ask you to multiply v times v. I could ask you to multiply w times w. Or if I asked specifically for the dot product of those two, you would be multiplying v times w. Okay, so let's just say that we're multiplying v times w, which would be the dot product. Okay, so those are your directions. Pretty straightforward. Okay, so I'm going to take my, this is a, this is b, this is a, this is b. So, can we do the math? 4 times a negative 3. We're going to add to that a negative 2, don't drop the negative, times a 5. Good so far? Negative 12 plus negative 10, so negative 22 if I didn't make a mistake. Okay. So see, simple. Not everything has to be hard. Not everything has to be hard. I would not have had that. That actually is the dot product because I took the two vectors and multiplied them. But like I said, I could have said find v times v. I could have said w times w. All right, so it doesn't make any difference there. You're expecting this to be hard. Yes. Okay. All right. Now, two more formulas. Okay. We always have alternate formulas. So I'm going to give you an alternate formula. Alternative formula for the dot product. Okay, if you remember, we had some formulas, I think on Tuesday, where we had the cosine of theta in there, all right, and we used the magnitude, all right, so if I've got two vectors, vector v times vector w, all right, that would be the dot product, okay. I can use the magnitudes and the cosine of the angle, so I could take the magnitude of the v vector, multiply that times the magnitude of the w vector, and then multiply it by cosine theta. Okay, so that really looks like those things that we were using on Tuesday. So if you happen to be given the magnitudes and the angle, then you'd want to use this formula. If you're given AI plus BJ form, you want to use the other formula. Okay, it's based on whatever you're given. All right, now, I think, didn't we on Tuesday do inverse cosine and we found some angles, right? We worked backwards and we found some angles. So I can also find an angle from here, okay, given different things, given the magnitudes of the vectors and all that kind of stuff. So I want a formula excuse me, for the angle between two vectors. And it's all based on that. Okay, so here we go. Theta is equal to, what do we use in our calculator when we're finding the angle? We're going backwards, so we use the inverse cosine. And then we're going to take the v vector times the w vector, or in other words, the dot product on the top. And then on the bottom, we will have the magnitudes. So the magnitude of the v vector times the magnitude of the w vector. And the reason I wanted to show you this is because this is just me taking this top equation and solving for theta. These two things are equivalent. All right, they have all the same pieces and parts. All right, it's an equal sign. I've got 5 things in there. I still have my, I'm solving for theta, so I've got my inverse sign, and then there's my inverse cosine, and then I've got those 4 things. It's the same thing. I just solved this equation for theta. That's all I did. Okay? All right. Now, I think I'm going to go to a new piece of paper because it gets kind of long. Okay, so we'll do an example of where we've got to find the angle. All right, so as an example, if they ask you to find the angle theta between the given vectors. All right, find the angle theta between the given vectors. So they'll give you 2 vectors. And again, for lack of creativity, I'll just call them v and w. All right, so let's say our v vector is, really doesn't matter. Let's make this a 4i minus a 3j. And let's make our w vector a negative 2i plus a 5j. Alright, I'm going to switch to red. Alright, so I'm going to start with the formula. Alright, we're going to use the formula. Theta is going to be equal to the inverse cosine, alright, of my dot product. Okay, so the dot product is, can we do the dot product? Multiplying the a's, multiplying the b's, add them up. Alright, so I'm going to multiply the a's, which is 4 and negative 2. I'm going to multiply the b's, negative 3 times 5. Alright, so there's my dot product on the top. Alright, now I want the magnitude of v and the magnitude of w. Do we have that formula memorized? The magnitude. So when I do the magnitude of, say, vector v, that's where we go a squared plus b squared and take square root. Remember that one? Okay. So if not, then you just got to keep looking it up if you don't have it memorized yet. But magnitude, a squared plus b squared, take square root. Okay, so I need the magnitude of the first one. So that's going to be, this gets kind of long, 4 squared plus a negative 3 squared and then square root. Alright, now the magnitude of the second one, so a negative 2 squared plus the b squared and then square root. See, that denominator gets really, really long. Alright, you really wouldn't have to grab your calculator yet. I'm going to do some math in my head here. Okay, so don't let me screw up. Negative 8 and negative 15. It's 8 and 15. 8, 9, 10, 11, 12, 13, 23. So negative 23? Did you really check me or did you just say yes? Okay, good. All right, and then this is going to be 16 plus 9. 16 plus 9 is 25. Square root of 25 is 5, so that number turned out to be 5. Again, don't let me screw this up. Negative 2 squared is 4. 25. 25 and 4 is 29, so square root 29, and then I'm not going to do a decimal or anything with that. All right, now I'm going to do inverse cosine. I'm going to put negative 23 on top. I'm going to put 5 square root 29 on the bottom. We don't need to rationalize because this is just a number, and I'm going to put it in the calculator because I want to go back and get my theta. So I'm going to let the calculator do all the work. Make sure your calculator's in degree mode. Okay, so inverse cosine, negative 23, 5 square root 29. And then who knows, because I made this up. Let's hope it works. Say what? Why didn't I? I didn't. I got that. Okay, so we good on that one? Pretty straightforward. Plug and chug on our little formula. Okay. All right. One more definition. One more definition, and then not a new formula or anything, but just a definition so that you can apply it. Okay. All right. There are these things called orthogonal vectors. Okay, orthogonal vectors. Obviously, I've got a plural. I got an S on there, so it means I've got two vectors. Anytime I have two vectors and the angle between them is 90 degrees, then they're called orthogonal. So if I draw a picture of it, okay, if I had a vector going up this way, we could call that the V vector. All right, and then I had another vector going out this way. We called that the W vector. Okay, well, doesn't that make a 90-degree angle there? All right, two angles that make, or two vectors that make a 90-degree angle, those two vectors would be orthogonal. Okay, so let's put a little definition here. Two vectors whose angle between them equals 90 degrees. Now, you don't want to have to draw them, okay, every time to decide this, okay, and you might not have enough information to do that. All right, so if they give it to you in AI plus BJ form, okay, that's the form we like, little A and the B in front of the I and the J. All right, then all I have to do is check the dot product, because if the dot product equals 0, I know that it's going to be a 90-degree angle. All right, so the other thing that we can put on here is that the dot product equals 0. Okay, the dot product equals 0. And so all I have to do to find out if two vectors are orthogonal, calculate the dot product. Comes up to be 0, the answer is yes. If it comes up to be any other number, then it's no. All right, and literally Math Excel is going to ask you the yes, no questions. All right, so if we go back to the very first one that we did, is this vector V and this vector W orthogonal? No, because I got negative 22. Okay, so all you literally got to do is check it, and if it comes up 0, then it is. All right, you want to do an example? Megan's like, no, I really don't need another example. Oh, let's just do one more for fun. Oh, yay. Okay, so let's suppose I give you a v vector, and it is 6i minus 3j, and I give you a double u vector, and it's an I plus 2j. Alright. Are these vectors orthogonal? And it would be a yes, no question. Okay, so the only thing I'm going to do, I'm going to calculate the dot product. Alright, so I'm going to multiply the v vector times the w vector. Okay, so we do the what? We take the a's and multiply them. So 6 times imaginary 1. And then we add to that the b's, which is a negative 3 times a 2. 6 plus negative 6. 0. Of course you knew I was going to make that one equal 0. So then the answer is yes, they're orthogonal.